Today's session would be on ArcGIS Runtime SDKs and building Android apps. I'm Rama Chintapalli. I work as a product engineer on the Android team, and she's my colleague Shuming.
Hello.
So let's see. This is the agenda for today's session. We'll give a little bit of introduction on where to get started for building apps. And then we'll talk about a functional overview of the SDK, kind of a very high level overview of how we design the API for you guys. And then we'll type into the SDK components, which technically are the building blocks for building apps. And then we want to showcase or highlight some of the example apps that we have so that you can go and play around with them. And then finally, we'll see what's coming in the future. Okay. So building ArcGIS Android apps, what exactly do we mean by that? Esri develops a lot of apps for you guys, and most of those apps are based on the runtime Android SDK technology as well. Some of them, for example, Navigator, the Collector, Explorer, all of them were built using the same runtime Android SDK. Similarly, you will find the iOS version as well. So if you're looking for an app that is already there, like if you want, if your workflow suit using one of these apps, you could absolutely go and use these apps. But if your requirement is to build something a more customizable app that suits specific to your needs, then that's where you probably need to get started with working with the SDK and build your own app that more suits your workflows. So where do you get started building such apps? The first place to go is developers.arcgis.com. That's our go-to place. You can sign up for an ArcGIS developer account. Is absolutely free. You get some free credits and you get some premium content, and then that's where you can register your apps that you're going to build. Obviously, you're building Android applications, so you need to have an IDE to work with, and that would be Android Studio, which is the default or the supported IDE from Google. So you can go there and download the IDE. The IDE brings in, like, you can install the SDKs with that. And then you need to have the Runtime SDK. So there are a couple of ways you can get the Runtime SDK. When you sign up for arcgis.com on the developers page, there will be an option to download the SDK locally. There will be a download button in the page where you can directly download the version that you want to work. Or if you are working through the Android Studio, you can add the SDK as a dependency in your Gradle module. By that, what I mean is, if you create a new Android Studio project, you will have a build.gradle file in your root project folder. That's where you need to add a Maven repository, and we actually host the SDK as a Maven repository on Bintray. So that's where you would get the SDK from. All you need to do is open the build.gradle file, add the Maven repository, and point it to esri.bintray.com/arcgis, and then add in your app module, just add the dependency as provided here. That's the package name and the product name and the version. And we are right now on the latest version of 100.3, which we released like a couple of weeks back. So that's it. If you're working through Android Studio, it's way smoother. Like you just need to add these lines of code, and you should have the SDK for you in your app directly, and you don't need any manual download. Once you have your SDK, either through the Gradle or downloaded locally, you can start building your apps. So if you want to build your first map app, again, you create an empty project in Android Studio. You will have a layout activity. You can add a map view component, just like the way you showed in the slide. in the layout.xml file, and then going back to your main activity file, you can on create of it, you can then get the map view component and then create a map using the ArcGIS map class, where you can pass in the base map type, the latitude, longitude, and the level of detail, and then set the map to the map view, and that's it. You should have your first Hello World app ready. We also support Kotlin, because that has been the trend Google has been going. So they're supporting more and more Kotlin, so you can develop, both are interoperable. So it's almost the similar code in Kotlin as well. So whether you write in your app or in Java or Kotlin, we support both of them, and we do have samples for both of them. At this point, I want to ask a question for you guys. Like, does anybody of you use Kotlin? Ever worked with Kotlin? Okay, that's good. So there are other SDK resources available for you guys. Like these would be the places where you can go to know what are the other SDK resources available. As I said, going to developers.arcgis.com, that's where you will see all the guide docs, the API references for the classes. There are samples available there, and there are details of samples explained. So I'll quickly show.
Quick question.
Yep.
The GitHub examples, are they only in Java or are they also in Kotlin?
They're also in Kotlin. The samples are. So this is the guide page, like the home page for Runtime SDK for Android. Like you can see, this is the button where you download the SDK right there. Some system requirements with 100.3. What we are supporting is we support API level 19 and above of Android. So that's something to note down. And there is the guide doc here. We explain the fundamentals of each of these concepts, and then we have the API reference, which explains what each of the classes does. We also have sample code, and they are categorized in logically, and then you can see, like, you can get the sample code from GitHub when you click these links. And these sample code and GitHub has both Java and Kotlin as well. So we have the developer side for all the doc. We have the samples code in GitHub. We also have something called example apps, which will cover a little more detail at the end of this slide, but you can think them as a slightly more advanced workflows than the samples. Samples concentrate on a specific functional area. Example apps would cover a particular workflow, and then those are completely open source. You can download, tweak them, and build your own applications, customize it. You can contribute to the samples and example apps as well. If you have any ideas, you can always go to this GitHub repos and post your ideas there. There's something new coming with 100.3. We now have a sample viewer app. So these are samples that are available in GitHub. So you need to download, open it in Android Studio, like build them and run them in an Android device to actually see the sample. But with the sample viewer app, which will be available pretty soon in a week or two on Play Store, where you can download, like you don't need to have any IDE for that. You just download it on your device, view all the samples, and then decide which ones you are looking for, and then probably go to the GitHub to get that particular sample. And there's an options to read the code as well in sample viewer. But so that's something available, will be available in a week or two in Play Store. We also have the GeoNet community where you can post your questions. That's the same that we use across the platform. So now we have seen how to get started with the SDK. So we'll take a moment to understand the overview of SDK, how we kind of build this SDK so that you get kind of high-level overview first, and then we'll probably drill down into each of those components one by one. So any SDK would obviously you need some view components to see the map, and the key component here are the map view for 2D and scene view for 3D, and both of them are inherited from GeoView, which is the base class, and most of those methods in those classes are inherited from them. And GeoView in turn is an view group, is an extension of the view group that comes from the Android SDK. So that's, and map and scene are the models that kind of fit into the view in the MVC architecture. And we have other view components as well, like callouts, magnifiers, like sketch editing, or map view grids, graphics overlays, kind of other view components as well in our SDK. And these views require some model, a source of data. So those come from the map or scene, which are map and scene are more like the containers for the source of geographic data, which in turn comes from layers and tables and things like that. So this slide explains those components, where they come from and the source from which they come. For example, map comes from can come from a mobile map package, which is kind of a local content which is authored on ArcGIS desktop, whereas it also can come as a web map from a web service, from ArcGIS Online or an ArcGIS Enterprise. Similarly, scene can come from a web scene, and each of these map and scene has a lot of layers and tables in them, which will go in more detail in further slides. But the key idea to remember here is that map and scene are the models for the views that we've seen before. And then to work with these maps, scenes, and layers, we have a bunch of other tasks and other components that are available, which drive the functionality around the map, scenes, and layers. And we have a lot of these, tasks we have, like locator for geocoding, routing tasks. There are like geodatabase sync tasks, where you can actually use those tasks to take data offline and then be able to edit and then sync them back to the services. We can have tasks for exporting the tiles services. We have tasks for exporting vector tiles. And we also have this exporting the whole map as a whole, like instead of like all these geodatabase, export tile, these are individual tasks on layers, but there is an offline map task where you can take the whole map offline, which is more of a convenience that we are providing. Apart from these tasks, like we also provide like portals API, like to connect with ArcGIS Online and work with those items. We support all the security that comes with the ArcGIS Enterprise. We kind of support all the security models, and we have some default UIs present in there as well. Obviously, we also need a geometry API to work with all these features that are coming from these layers, and then kind of a symbology API to render them and visualize them better. That's kind of a high-level overview how we segregate the API. Now let's slightly dive into the individual components, which are like more like the building blocks if you're trying to build an app. As I said, the foremost important thing is the map or scene view, which is the view in the MVC architecture, which displays the scene. Some of the common operations on a map view would include like changing the viewpoint, or like when do you, or some events like map navigation. You want to know when the map navigation started, ended. You want to work with graphic overlays, where you want to show some graphics on your map view. You want to perform some operations like identify on a map. Also, you want to have some touch events happening on the map. Just like any other Android view, you want some touch events happening on defined on an map view as well. We provide a default map view touch listener, but you can always create your own custom touch listener as well. We also have a camera controller for 3D scene. These are like some of the operations on that. And then, as I mentioned, there are other view components associated with the map view, like the callout attribution or magnifier, like a 2D grid or location display. Like if you want to have your app kind of support the GPS of the device, you can use the location display for that. With that, let's see the sample viewer and some of the demos for some of these components that I just mentioned. So here is the sample viewer app, which you're soon going to, like everyone will have it from Play Store. So we categorized all the samples into different categories. Let's go into the map views and scene views. So let's see a change viewpoint sample. So this is how the UI of it, like based on category, you can go to the sample, you have an option to read what the sample does, and you can actually see the source code of it as well in this right here from your mobile device. You don't even need to go to the GitHub to see it. Then you can obviously view the sample. So this is a viewpoint that was set. You can set your viewpoint by geometry, like you could define a geometry and say zoom to that particular point. You can center around a certain point and use a particular scale level for your tile layer. You can animate your map, so that has the animation effect on your map view. So that's how the viewpoints can be changed. The next sample I'm going to show is about the location display. This is like when your GPS is turned on the device. I switch it on, the location display, and then so there are different modes for location display, and one of them is like recenter mode, which kind of recenters your map whenever you use this mode. There is a navigation mode if you are using it for navigation purposes. Actually, it will show a different symbol, navigation symbol, if it has some velocity. So if your vehicle is moving or if you are moving, then it actually will show a different symbol in the navigation mode, and the map kind of pans around it. And then there is also a compass mode, like if you are using compass, like you can see that the map rotating automatically based on the direction of it. So you can use this location display in your apps as well. The other one I wanted to show is there are grids, different types of grids where you can change the style of it. There's an MGRS grid. There's an option to select the color and things like that. You can switch on labels on and off. So basically, you can use the 2D map grid as well. This is currently only for 2D map view. So there is a callout. If you want to show some information on the map, like you can, for example, in this case, I'm just touching the map and I want to just show lat long. You can show it in a callout. And this callout can actually hold a lot of other things as well. You can plug in any other web view, like you can put images, any custom HTML plugged into the callout as well. So it's more powerful for visualizing geographic content. We also support the magnifier. Like if you want, so if you just press and hold, like you can see that the magnifier gives a kind of a zoomed in version. This can be especially used for like editing purposes, like if you want to really find finer details on the map. There are also other samples like taking the screenshot of the map and things like that, but so we'll restrict that for now for map views. So obviously we saw the view, and the view has to be powered by the model, which is the maps and scenes, which are very powerful. They combine, this is like the central concept across the ArcGIS platform. Map is the container for base maps, operational layers, like any non-spatial tables that you have, or elevation sources, location and network datasets, like bookmarks that you define in your ArcGIS Online. This map has the same schema, whether you're working with online or offline, whether you're working with Pro, Runtime, ArcGIS Online. So the concept or the schema remains the same, and it's fundamental because you can open these maps in any product, edit them, share them across the ArcGIS platform. So let's see some demos on the map and scenes. I'll switch back to the device. So this is again a map view that's showing a map with some base maps. There's an ability to switch base maps, like you can choose a vector navigation vector base map, or you can choose a gray canvas base map. Like you can just quickly switch from map. Like all you need to do is map.get base maps and then switch those to a different base map. This is how a scene would look in an app. Again, scene also has the schema would be the same. It will have some base maps, operational layers, and things like that. You can manage operational layers. So if you have multiple operational layers, like you can remove them, rearrange them, reorder them. For example, I remove the census layer, and I click, and I can see that the census layer is removed from the map. So I can go back and add it back whenever I want through the app, and it should come back on. So you can manage those ordering of operational layers. Again, as I mentioned, you can get this scene from a portal item that is hosted in ArcGIS Online. So previously we have seen a scene that is loaded from the client side itself. This one is actually getting the scene from a portal item. So it clearly integrates with the rest of the ArcGIS platform. And the other thing I wanted to show is the sketch editor. So we provide within the API and convenient utility, the sketch editor, which helps for you if you're building some editing apps that require editing. This is very convenient for you to use this instead of building your own kind of a sketch tool. This one really helps in the editing applications. So you can select a point, drag them. You can undo the sketching, redo the sketching. Once you're done, you can just get the geometry that you sketched, which is very powerful. And then we have freehand sketching as well if you want to use it ever. So we support all types of geometry sketching here, and this sketch editor is mostly 2D. There's no 3D sketch editor yet. And one last thing in maps I wanted to show is the surface placement on the graphics overlay of the scene. You can see the graphics added here. Like you can choose the surface placement, whether you want the surface to be placed or the graphic to be placed along the surface of the scene, or like you want to put it at a particular height or relative to something. So you have these modes, different modes: draped, absolute, and relative. Interesting, it's not switching. Okay. Oh, I never knew that we could show both of them together. So let's see the layers. Layers are the source of the geographic content, and as I showed in one of the previous slides, there are a number of things that you can do with the layers. Like you can change the rendering of the layers, visibility of it. There are a lot of other properties for the layers, like you can set layers visible based on max and min scales, the extents of the map. You can have your own attribution defined on layers and things like that. Some of the layers actually support time as well, so that's another key property that you need to be aware. But the key decision when you're building apps for you is to choose like which kind of layers really I want to use in my app. So you need to think about your users. What do they really want in their app? Do they need any way to compare data with time? Do they always want to be connected mode and work with services? Does they require any kind of querying and analyzing abilities on the data or selecting? Does it require the ability to be edited, or some layers where do they really need control over the style of the layer? And of course the interoperability with the ArcGIS platform, do they really need? So these are some of the questions you need to probably think when you're trying to see what kind of layers you want in your app. And coming back to this old slide, for some reason the other HDMI is blocking it, but you get the overview of the different types of layers we support. We have the ArcGIS tile layer. We support vector tile layer, map image layer. Again, it's coming from the map service from ArcGIS Enterprise. We support raster layers. We also support custom tile layers. You can extend this web tile layer and get from a third party a tile layer, and then you can build your custom tile layer as well. We support a lot of OGC layers like WMS, WMTS, big maps, ENC, and OpenStreetMap layers. For 3D, we support ArcGIS scene layers as well. If you want to work with vector data, then probably feature layer, you want to work with feature layer, where you can get the data from a service through a service feature table. Or if you're working with the local geodatabase where you kind of downloaded the service offline and then you want to work with the local data, you can work with the geodatabase feature table. We also support shapefiles through the shapefile feature table, and the OGC geopackage packages as well through geopackage feature table. With that, let's see some demos on layers. Okay. So here is a vector tile layer. Like we support different styles for vector tile layer. This is like a mid-century vector tile map. There is a colored pencil style, which is really nice. There is like this Nova vector tile. Really, depending on like what kind of style you really need for the look and feel of your app, you can choose them. And then we have feature layers from geodatabase. And the good thing about the sample viewer app is if your app needs any data, it will ask you to download, and it automatically downloads from ArcGIS Online. So in this case, I already downloaded the data. I don't want to re-download it. I just say OK, and it just loads from the local geodatabase. So we, as I said, we also support geopackages. You can see the data that is coming from geopackage. You could see that it's all black. It doesn't have any symbology or renderer defined, because by default geopackage doesn't have it. Like we need to set a default renderer to it. Similarly, we support shapefile as well. There's an OpenStreetMap layer as well that we support, and we support raster layers from a file. So like this is a raster file that is side loaded onto the device. Like we support those as well. So geopackages also have rasters. Geopackage is basically a container of raster data as well as vector data. This sample shows how to get raster data from a geopackage. So this one is showing raster around the Aurora. And then we have a scene layer as well, which should be coming from a scene service. Like you can So those are all the different types of layers that we support. There are more, but you can go through them. We'll not go through each one of them here. So now we have seen layers. Let's look at some visualization. Shuming is going to go through some of these.
Thank you, Rama. You have seen that you are able to add different layer, different data to the scene or to the map view. Let's take a look at how we can change how the layer is rendering in 2D or 3D. First, let's take a look at symbol. Symbol specify that the non-geographic aspect of a feature or graphics, how they look, such as the size, the color on the border, or the transparency of your graphic or symbol or feature. You can apply a symbol to your individual graphic when you create a graphic with a symbol. And right now, currently in runtime, we support two types of symbols. One is the simple symbol, which is follow the web map specification. And when you can access this kind of symbol through simple symbology API. And another type is the advanced symbol. These symbols follow the ArcGIS Pro symbol model, and you can access those symbols through the multi-layer symbol classes. And you can also use the symbol to define a renderer. For a renderer, it will determine that how your graphics in a graphic overlay or the features in a feature layer look. You're using the renderer to do so. And when you define a renderer, the renderer will use the symbols to render your graphics or your feature in both 2D and 3D. And that's a list of the renderer types we support right now. I won't go through all this. We can take a look at different render type when we show you the samples through the sample viewer. And that's in runtime, we also support styles for some of the layer types, such as vector tile layer and also WMS layer. They don't support symbol and renderer. Then we will use a style file as an alternative. Rama already showed you that the vector tile, you can use different styles to render those vector tiles. And for WMS, the server will define some options for you, the style option. Then you can pick a different style option when you render the WMS layer. And also, that's a different raster renderer for raster layer, which only apply to a raster layer, and it will just change the display property of a raster layer. Here's also several raster render type we're supporting right now. And let's take a look at the demo. First, we take a look at some create graphics using different symbols. Here you can see we have some point. We have some point using the marker symbol to render them, and we also have the line, polyline, and this we use a simple line symbol to render those as a dash line. And here you can see there's also a text symbol. We render it through a point geometry. And that's a polygon. We using this when we render this polygon. There's two symbols here. One is for the line, for the border line of the polygon, and also the filling of the polygon. So we're using a simple line symbol and a simple fill symbol to render this polygon. this. And you can see we had a brand render. This is for raster layer because it will take a bit, so I won't show it here. And here's the color map renderer. I already downloaded the data, so this is the color map renderer. It's also a raster renderer. It applied to a raster layer using the color based on the value of the raster layer. And feature layer, this is in a SceneView and use a blue color, simple view symbol with blue color to render this feature layer in a 3D view. And here you can see the in 3D, that's an extra parameter for the scene renderer is the extrusion mode. I set this extrusion mode to the absolute height of the Z value, and I can also set expression to specify the height. And based on an expression here, this height right now is based on a total population, and I can change the expression to use a population density. You will see that it will render differently here. So that's huge A render. It's also a raster render and RGB render for raster layer. Here's I want to show that's the change the style for WMS layer. The WMS server offers two styles here. This is the style 0, and I can change it to style 1. You will see the look and feel of the WMS layer change. That's all. Now, let's take a look at how you be able to search or query the information in a scene or view, because the map and the scene will combine multiple layers, such as feature layers, map image layer, or scene layer. So you will want to find the information you're looking for. Let's take a look at identify. Using the identify method, that's through either a map view or scene view, you can answer a question like what this item is in around here by tapping or clicking in the map view or scene view. Then allows you to explore and learn what the content of the scene or the map. And that's a different use case using identify. You can identify all the layers in the map or in a scene, or you can only specify a few layers or some graphics overlay in your map or scene. And when you return the data, you can specify you only return the topmost or return like a certain amount of items from the result. Or you can either also create a pop-up for some of the items and return the pop-up with the items. And that's a list of the layers we already supporting identify operation. And that's another type of search, is the praise search. You can input some strip name or the name of point of interest, and then we will looking for the location in the map of scene. And this process that's to matching the location and the name and display in the map of scene is called like a geocoding. The geocoding works with both offline and online. If you have the locator database stored on your device, you can work offline. And here's a common workflow to work with the locator task and specify the parameter and execute the task and get a result back. Now let's take a look at some of the identify and price search. See, you can like specify. You can identify a symbol in a feature layer when you and highlight it and select it. You do see that around 5 features have been identified. And you let's take a look at the price search. Here, that's 2 parameters. One is the name of the street or the name of the point of interest. Like say, you may want to grab some seafood. After that, when you type, we will provide, you can see the drop-down list. We'll provide some suggestion for you and to save you some time. And I can search, select seafood, and you will, based on the current location, you'll find all the places that match this seafood keyword. And or you can also specify a location, maybe after the UC, you may go to Los Angeles, and you can search some seafood restaurant in Los Angeles. When the result return, you can zoom over to see the result, and you can tap on the result and see where it is, and you can work with the route task to do routing from like San Diego to Los Angeles, which I won't show it here. That's the price search. And you can also identify all the layers in a map view. Okay, looks like some of the layer doesn't render. Let's skip this demo. Sorry about that. We can look at doing identify a selection in a sim view. The scene layer will render. Sorry, it crashed.
Need to check the internet connection.
Yeah, could be because I load the scene layer from a portal item, and when you tap on the scene, it will select this item in the scene view, or I can select a building in the scene layer. Yeah, that's the identify and highlight and selection in a scene view. Let's go back to the slides. Back to you, Rama.
So we have seen how to visualize query. So now let's look at how to edit and manage the data. So basically editing is this ability to add features or update features or delete features. The workflows here can include, like you are working with a connected service, like working with feature services from ArcGIS Enterprise or ArcGIS Online, or it can be offline workflows where you take the data offline and perform edits on those and then synchronize back. Again, we support all the different types of offline workflows. There is a separate session if you want to attend that for building offline applications, which is happening right after this in this room. So we also support downloading pre-planned maps from ArcGIS Online, where you take offline, you can make edits and then sync them back. We also support editing standalone like local data like shapefiles, geo-packages. So we support all of those. We also support transactional editing for local geodatabases. So what transactional editing means is if you're working with a local geodatabase where you took the map offline, with the data offline, and then you started editing stuff, like you can now start edit things in a transaction where you can start edits, perform some edits, and if you don't like the edits that you made, now you can roll back your edit to the last point where you started your editing. So there is an option where you can collect all the data in the field the whole day and then still choose it to roll back which we didn't have before. So you can do the transactional editing. We also support editing related features, attachments, and we track the users who are editing the features, and we support the ownership-based access control that you can define on your feature services on ArcGIS Online or Enterprise.
Is the syncing bidirectional or one-way?
The sync is bidirectional, yes. So there are different sync parameters that you can set. You can choose to include attachments, exclude attachments. So the whole list of parameters that are available in sync as well. So let's see some demos with editing and managing data. So this one, this is a connected service where you just want to update the attribute information. So I tap on it, I select the feature, it shows the type of the damage. It's a minor one. I change it to something major, and then it automatically connects and applies the edits to the server, and then it changes the symbology immediately based on the attribute change. Like if you want to update the geometry, this one, you can tap on the feature, move it anywhere you want. You can see that it immediately applies edits to it. So immediately it applies to the server as we keep editing. So here is an edit and sync where I choose a specific area. I try to generate a geodatabase. Let's see this. I think this service probably is down because I don't see the service. Let's wait for the service to load. So the way the whole offline workflow, as I mentioned, you can come to the next session where we clearly go into the different details. Yeah, looks like the service itself is not available. That's one of our sample services, and people keep really hitting hard that service, and that keeps going off very often. Basically, but the workflow is you can specify the area on demand, the area that you want to select, generate a geodatabase from the service. You can perform edits locally and then sync them back in whichever direction you want. We also support attachments and relationship data. We also support the mobile map packages actually, which are like the local content that you can create from ArcGIS Pro or any desktop app. This is completely local data. There are more samples there. I'm looking for relationships one. Okay, it did too. So I select a feature. So it does the identify, and then actually there are two different layers in this where there's a park and there is other information like annual visitors coming from another related table. We can directly go and update that service with the annual visitors that are coming. So it immediately applies those to the service. So the idea is, again, we can work with related tables whether you're connected or disconnected. Okay, that's the samples for editing. Let's see some analysis. Shuming will go through that.
Yeah. First, you have seen how we can be able to do some search and query, but that's not enough. With so many data, you have so many information in your map or scene. You also want to do analysis using those. one way it's like a job processing. You already when using the ArcGIS platform, you already has defined some geoprocessing tasks, and once you publish those geoprocessing tasks, you can consume the services, the web services, and its task in the runtime through the REST endpoint. And there's a few classes here, and you can have an idea how we are able to support geoprocessing tasks, different tasks like buffering or doing hotspot, etc. And the workflow is the same no matter how you define your geoprocessing model. And another kind of then that's the common workflow is that for geoprocessing that create a geoprocessing task using your geoprocessing web service URL, and then specify the parameters, etc., and create a job from the task and execute a job and get a result from the task. That's the common workflow. And another kind of analysis is you can do analysis using the scene, using the data. Start from like runtime 100.2, we introduced two major classes. One is analysis class and analysis overlay class to help you to dynamically and fast visualize the result of the analysis. And currently we have, for analysis, we support line of sight, location, distance measurement, and view shed. And we will adding more and more in the future releases. And you can add the analysis into your analysis overview, and in turn you add the analysis overview to your SceneView. Then you can dynamically visualize your result. And you can also control the visibility of your analysis using the overlay. And that's a common workflow of using the analysis class and analysis overlay to do analysis in 3D. And let's take a look at the demo. Looks like we don't have much time, so I will skip the geoprocessing, using geoprocessing to do analysis. Let's go directly to the new feature, which is the 3D analysis. We had some view shed and line of sight. Let's take a look at how we are able. You can see that you can also do view shed using a geoprocessing tool. Which I won't demo here. Let's take a look at a view shed in 3D and how you can able to change the parameter, and immediately you are able to visualize the result of the analysis. When you change the zoom in and zoom out and change the viewpoint and camera, you can see it render. And here the view shed is the area you can see is in green, and the area you cannot see is in red. So we can change parameter of the analysis. Like say you change headering, and you will see that it dynamically change the result. And you can also change the angle, change the distance. So that's the analysis in 3D using the analysis and analysis overlay classes. Let's take a look at how you can access your content through cloud or portal. First, we can take a look at authentication. When you work with portal, ArcGIS Enterprise online, you need to go. you may need to access some secure content. So that's the authentication come into play. And dealing with security, it demands a lot of work. So we try to abstract as much as possible the authentication logic into a component called Authentication Manager. This is a central place you can deal with the authentication challenge and also manage some in-memory credential cache and work with OAuth and also manage your client and server certificates. And we provide a default implementation to dealing with the authentication challenge. We call it default authentication challenge handler. This handler provide default UIs when you different kind of challenges are issues, and you also manage passing the credential to the authentication manager. The authentication we support full. We provide full support authentication to allow you to access content in online and portal, including HTTP, basic, digest, and token base, OAuth, and certificate, etc. And also allow you to trust self-site. This is the UI for different challenges. And that's OAuth. We support OAuth 2.0. You may already actually use OAuth when you log in an app using your Google Plus account or your Facebook account. That's OAuth. So the default challenge handler provide you to dealing with the OAuth 2.0. And Portal, it's a high-level developer gateway to access your information. Allow you to access, use, create, or share your content in Portal, online, or ArcGIS Enterprise. And that's some common workflow. Then we can see that through demo. Okay, that's we can take a look at how the authentication work. So because I want to access the portal as a name user, so the challenge is issue. That's the interface. I can input the name, and then I input the password and login. After login, I can fetch the profile of the user, the login user, and show the information. Okay, this that I pass back to Rama to take a look at example.
So
app.
we just want to mention about example apps, so that we have a Maps app, an EMU app, there's an EABA app, there's a mobile offline data collector app as well that's going to be available on the example apps. So what we want you to try is go and try these. Some of them you can probably use it, especially the mobile data collector one might suit you, where you can download that and then customize it and then extend your app based on that. So we try to follow really good design practices while developing these example apps. So it's a really great place to have here. And if you have any suggestions for example apps, you can, for us to build, you can always suggest us as well. So quickly, what's coming in future? So there is one important thing is Google has a deadline for Play Store apps. If you are already using Runtime, and if our native libraries right now are 32-bit, and Google has a deadline of August 2019 where they want all the apps in the Play Store to upgrade to 64-bit libraries, native libraries. So for that, we are soon going to release, our next release is going to have those so that you have enough time to upgrade your apps if you already have 32-bit libraries in them. So we're going to do some improvements to the 3D as well. There'll be a KML support and then some new raster format, and also going to support WFS, and there's going to be a whole new symbology model where a multi-layer symbology model is being done in the works. So something to watch out, and there are more stuff coming in. Like, it's just that it was not immediately planned or anything like that. But you can always give a feedback on, like, if you need anything specific features or functionality, you can always give us the feedback on that. So with that, we saw the introduction of getting the SDK, overview of the SDK. We saw different components. We haven't seen all of them, but most of them. We just slightly talked about the example apps and the availability of it, open source availability, and we saw what was coming next. That's all we had. Please take a survey of the session. You can go to your events tab and then rate the session. And if you want the content to be slightly different, if you want more demos, less content, or more content, less demos, like, you can give all kinds of feedback there on your app. With that, thank you.
Thank you.
Thanks for attending the session.
And if you have any questions,
if you have any questions, we'll be here. Like, you can come and ask, or you can raise now. Yeah.
Example stuff that are on GitHub. Is there like some good labs maybe for how to piece some of the stuff, the examples together? I was able to get a few of them to work together. I just don't have.
So there is something called ArcGIS Dev Labs as well, which also is slightly different from the example apps. Example apps more like open source. They're all available in GitHub. So there's ArcGIS Dev Labs. There should be an island in the product showcase where they can probably give you more details on the dev labs, what you can do and what, how to register and things like that.
Yeah, that's kind of what I ended up running into. It's like I could get the example of work, I might add maybe 2 examples together.
Right.
But I really started to try to build out, a full app with the SDK
Right.
with everything in it. And I ended up running into a lot of errors, so it would help me to do something like that.
Yeah, we can also give the feedback in the dev labs, maybe if they have certain workflows that you want to include in the dev labs. Like, if you're looking for that, you can always suggest us, and then we will probably try to organize the dev lab in such a manner.
How in sync are you guys with the iOS side?
So all runtime SDKs are on par with the functionality. Like, if you see the API design, the classes, everything are named exactly the same. So we almost try to stay on top of it, where we always release together, and our internal architecture is such a way that we almost consistently have the same functionality. So if you are building for Android, it's almost like all you need is a developer who can just port the similar code into iOS.
Question.
Yeah.
One of the pain points we have right now is the size of the SDK. I know that I talked to the iOS guys. They said that they have trimming, which is still a lot better than Android side.
Right. There has been feedback on that, on the size of the SDK, especially with the runtime native code being growing bigger. So there are plans for kind of optimizing
Modularize,
it and modularize it. So that.
How big is it currently Android? Because I haven't started looking into Android just yet.
Yeah, like so the native library itself is about 30 MB or something like that. The app itself, the whole of it, depending on the size of your application code as well, can go up to maybe more than 50 megabytes, which is sometimes is big. Yeah. Yeah.
I think that lady has, please.
Yeah.
Yep.
When you're going to download it, is it at that page, or is it the same version that you get in your organization's downloadables?
Yes, like based on the version number that you specify, you will, if you include it in Gradle, you will get that particular version. And when the download page, you have all the older versions, so you can specifically choose which version you want to download.
So I can just go to my organization.
Yeah.
Download. Okay.
Yeah.
Yep.
Yeah.
Yep. Okay. Thank you.
Good. Thank you.